Lesson 3J, Math with sig figs. Let's look at adding and subtracting sig figs. We're going to add these 5 numbers. Plugging these numbers into our calculator, we get the answer 40.0618 seconds. If we look at these measurements closer, we notice that 3.1 only has the precision to the tenths of a unit. We don't know what digit belongs in the hundredths, thousandths, or 10,000ths of a second's position. We can also see that in our measurement 3.55 seconds, we have no digits in the thousandths or 10,000ths, and the measurement of 2.703 seconds, we don't have a digit in the 10,000th position. This means that there is uncertainty in the hundredths to the 10,000ths position. This means that we must round to the tenths position, as all the other values smaller than the tenths are uncertain, making them insignificant. We would round this number to 40.1 to match the precision of 3.1. The rule for adding and subtracting sig figs is to round your final answer to the decimal place of the measurement with the least precision. We can only trust the least precise number. Let's try this example. Plugging these numbers into our calculator, we get 181.0864 meters. Some people would identify that 3.9 has the least precision. However, the least precise measurement is 160 as it has no decimal value, so the least precision and the significant figures are 1 and 6. It's only significant to the tens. Our final answer must be rounded to the tens, which is 180 meters. Try these. 17 centimeters. The 3 centimeters has the least precision ending in the ones, so we must round to the ones. 653.800 seconds. 1006.353 has the least precision ending in the thousandths. We must round to the thousandths. 1490.1. The 34.2 moles has the least precision ending in the tenths. We must round to the tenths. Multiplying and dividing rules. Let's multiply 5.2 centimeters with 7.1 centimeters. If we plug these into our calculator, we get a value of 36.92 centimeters squared. Now looking at these numbers, we see that 5.2 centimeters has precision to the tenths. 7.1 centimeter also has precision to the tenths. Multiplying these two numbers gives us more precision, 36.92 to the hundredths. How can this be? The rule for multiplying and dividing with sig figs is to round your final answer to the measurement with the least number of sig figs. Since 5.2 and 7.1 both have 2 sig figs, our final answer is 37. When multiplying or dividing your sig figs, round your answer to the least number of sig figs in your calculation. Remember to use your rounding up or rounding off rules that you learned from earlier lessons. Let's try this example, 4 kilometers times 12 kilometers. Our calculator gives us 48 kilometers squared. 4 has 1 sig fig, while 12 has 2 sig figs. Our final answer must be rounded off to 1 sig fig, making our final answer 50 kilometers squared. Try these examples. 2.0 times 10 to the 2. 6,400 had 2 sig figs, so we must round to 2 sig figs. 7.2. 1.3 has the least sig figs of 2, so we must round to 2 sig figs, 7.2. 0.15, or 1.5 times 10 to the negative 1. 8.4 has the least number of sig figs, so we must round to 2 sig figs. When using these sig fig rules in mathematics, you must remember to use the order of operations BEDMAS. Keep track of your sig figs while you're doing your arithmetic and only round your final answer. Let's look at this example. Now, our order of operations states that we must do the multiplication first. Our numbers have 4 sig figs, 3 sig figs, 4 sig figs, and 2 sig figs. When we multiply 105 with 0.0535, we get 5.63355. And when we multiply 216.5 with 0.014, we get 3.031. If we use our proper rounding rules, then our first product should round to 3 sig figs, while our second product should round to 2 sig figs, which would make 5.63 plus 3.0. However, we only round at the very end to our final answer. Now, if we were to round, you can see that our 5.60 rounds to the precision of the hundredths, while our 3.0 rounds to the tenths. Keeping that in mind, we can properly round our final answer a little bit later. When we add 5.63355 with 3.031, our sum works out to be 8.66455. Remembering our sig fig rules for addition, we must round to our least precise value, which would be 3.0, which is the tenths. Our final answer is 8.7. Please note that we only round at the very end. We must keep track of our rounding rules during the whole process to ensure that we get the proper answer. If we would have rounded during each stage, then our answer would have been 5.63 plus 3.0, making 8.63, 4.6 times 10 to the 2.